I had to have a banana for scale to show you how to build a custom designed 3D printer. Stay tuned and I'll go over the printer and the basics for everything, and I'll explain more in depth with the series as I go along on how to build each part and design everything, as well as the other part of the series where I'll actually be building this in real life and showing you the process with that too. Anyway, stay tuned. Everyone, this is Kevin with Inventimart, and today I'm going to be starting a new series as well as continuing the old series of the Blender how-to, basically for beginners in 3D printing. But for this series, I'm going to be showing you how to design and build your own 3D printer. I've already built one printer by myself from scratch. I had help from a friend. He actually 3D printed some parts for me so that I could make the actual printer to begin with. But for this one, I actually have that printer that I first built working, and with that I've actually been able to print all of the parts that you see that are in orange here. Some of them are a little bit different than I have in here, so that I'm not using the exact same parts, but most of them are these actual parts. These are the actual 3D models for those parts. But what I'll be going over is basically the design concept and kind of the parts that you have to source out of what kind of printer you want to go for when you build it. Like this one is a X and Y axis. It moves along both of them. The print head does. It moves on the top, and the Z moves up and down by itself. My other printer is the Y moves by itself back and forth on the bottom, and the X moves along with the Z axis, and it moves up just like the Prusa i3 printer. This one's more like the Ultimaker, I think, but I actually didn't take any plans from any other printer that I know of. I just put this all together myself. But the hardest part to find for a reasonable price was the steel rods here, and I was actually able to get those. And the glass I actually still have not found yet. I have some pieces that I can use, but the aluminum plate was something that was also more expensive. Those are actually the most expensive parts besides the motors. But the basic concept you want to start with is the finding the parts that you want to get and what style of printer you want to make. Do you want the printer to be like this type of printer where the print head moves around independently of the Z-axis, or do you want the X-axis to move with the Z-axis and go up and down? And that's basically your first decision that you want to make, is what style of printer do you want to make. And the second thing would be, how big are you going to be making the printer? This one right here, the rods that I'm using are 600 millimeters in length approximately, and I already have them in their actual size, and they actually do measure to 600. But and they're 12 millimeter round, and they're that thick because this is a rather large printer. The printable area is going to be about 53 centimeters, or about 19-20 inches for X, Y, and Z. So it's going to be rather large. So, because the one I have now is only a 200 millimeter approximate by 200 by 200. It's actually smaller than that. It's like 180 by 180 by 150, but you get the idea with that. But for this one, or for the main process, you want to pick what size you want to get and the availability of the materials. For example, like these rods here, I went with 12 millimeter because they're sturdy enough and rigid enough that they'll hold up to the weight of anything, so there won't be any warpage while it's printing or anything like that, because that's an actual very important thing. And another thing is the frame, where you want to build the frame out of. I'm actually building the frame out of angle iron steel. It's 3/4 inch by an 1/8 inch thick, and hopefully it's going to be sturdy enough. I don't know yet. I actually haven't put it together quite yet, but I have all the pieces cut. One of my friends has this channel, Permofit. He helped me out and let me borrow some of his tools to get the pieces cut, and he actually got the metal for me too at a pretty good price. But the frame, you gotta figure out what type of construction you're going to use, because if you build it out of aluminum plate like this, the one I got was about $17 US, and it was it's a 6mm thick. It's pretty heavy actually. It's 11 pounds, but it was the shipping was $17. The plate itself was about 30, and that's actually not that bad of a price for that big of a chunk of aluminum. But if you wanted to make like the tower of like the XZ axis type printer, that would be kind of expensive to do, and then you can source metal threaded rods to make the parts and do it that way. And it's pretty much up to you. The hardest part is finding the rods, and you want to figure out where you want to get those from. And once you get those decided, the next step is to pick how long they're going to be, and once you source the material, you can cut them to the dimensions that you need. These ones were actually just 600, so I built the printer off of that specifically, that specific dimension. It all started with that. And from there, I picked the Z-axis, and I was able to find some threaded rod of this stuff for a reasonable price. I think it was about $12 each. I got them from Banggood. This is just the ones with the brass insert. I don't know where it happened to it, but it's not there. And I actually modeled everything in here so I could look at my design and see if everything was going to be working just fine. Yeah, there it is. And so I put everything together and built every part one by one, put everything kind of where I thought it was going to be, and moved everything around and made sure there was clearance for everything, like the belts and all of that, and the pulleys here, made sure they worked, and make sure everything has clearance. Like it's going to be a tight clearance for a few things here, like the belt on the axis here is going to be kind of up high, and for each pulley and everything, I didn't make the entire belt, but when you look at the specific parts, you can tell kind of what's going to go where, and building it first in Blender helps a lot. My first printer, I didn't build the entire thing in Blender. I built kind of like the main parts that I thought I was going to need, but for this one I built the entire thing, which helps a lot. And because before, when I did that, I wasn't that good at Blender, and I could only do the basic stuff, but now that I'm a lot more advanced, I can basically build whatever I want with it. And so once I got all the dimensions built and everything mocked up, I sourced all the parts that I needed, like the screws here. I actually designed the screws individually and made these exact, because Blender actually has a tool where you can make the bolts, and you can pick out what size over here. These are M5, and you pick the thread length that you think you're going to need, and the ones that I got were 20mm. And to size up the bolts, just go by 10, and that goes to actual size, even though it's way far away. I don't know what happened there, but if we zoom in here, and see, I didn't change it. I didn't change it to the Allen wrench. It's just a regular bolt cap. You can use whatever you want with that. I prefer these because they don't strip out as easy, and they just seem more rugged. And you need the bolts, and so you kind of want to place all of those around and figure out how many you're going to need for the entire project. See, with just this one one corner here, I'm going to need 2, 4, 6, 7, 9, 11 bolts on each. That's pretty much the same for all of them. So that's 44 bolts at least right there. That's taking into account all of them. So 44, 45, 46, 47, 48, 49, 50. I'm actually going to run out of bolts just now. I just realized that. I'm going to have to order more. And until I do, I can actually get by with only using partial on them. There's some that I'm absolutely going to need, like the extruder motors here. I have the mount and the holding those up, and these are mounted to it with that. Excuse me. And the next thing you want to do is bearings are very important. Like these right here, you can actually use the LM8UU or the LM12UU. Those are the linear bearings that most all printers have, but the reason why I built this printer without those, I'm using just round bearings that normally would be used for just not typically this type of application, but the LM bearings, they have the little tiny ball bearings that grind into the metal rods and it wears the rods out over time. And paying so much for these, I didn't want to have that happen, so I just decided to go with a bearing that would just roll alongside it smoothly and not wear into it as bad. And so I designed these. These are the basically they have 3 bearings around it in 2 different spots, and they hold the rail in place. And I actually have a different design for those now, but these are, I'm still using these same ones on the Z-axis. These are the ones I actually printed, and they actually work really good. Because when I designed them, I just matched the dimensions exactly, and any printing tolerances didn't really seem to matter. Because when I put it on the rod, it actually was really smooth and it worked well. And so for each one of these, you're going to need whatever you decide to hold the bearings in. If you decide to go with this method, you'll need the bolt and the nut for each bearing. So you got to multiply that and count those. I have all those made already, so I know I have enough bolts for that. And the next thing would be like pulleys. Like you definitely want to make sure you have pulleys. There's these type of pulleys. With this particular printer, I'm using these pulleys here. How this particular axis is going to work is this motor here. I'm going to have a small pulley on it, just like the one I just showed you, and then it's going to be a 16 tooth, and then I have a 36 tooth, I think is the size, going right here, and this rod goes through, connects to this bearing here, or this pulley, and there's bearings on the other side, on the inside of this too. Like there's one there, and there's one here, and those are the 5mm inside diameter. Just match the motor and the pulleys, make it really easy. And I'm going to have a link here between these two, and I already have the metal rod for that too, and it's going to actually be driving both of these pulleys with belts on both ends. So both of these are going to be pulled at the same thing, so not just one of them's pulling, so it's not going to drag it, so it's going to be more precise and less chance of jamming up. And so it's going to move that. And the same thing with the other axis. It's got the belt on both ends. There's this one, and then there's this one. If I can get in there. They got another one here. That's the 16 tooth pulley for all of those. And I guess the next important thing that you'd want to pick would be what type of extrusion you're going to want it, because you can have, like I have here, like a Bowden setup where the drive motors are away from the end that moves, because you want to have this as light as possible for quicker movements if you're planning on printing fast. The direct drive works a little bit better because it's right there and there's less chance for it to snag or mess up or anything like that. But the direct drive just drives it down. But the Bowden here goes directly in the hot end. I have this whole middle piece all built and ready to go. I just haven't imported it into this file yet. But the extruders that I decided to go with were the E3D type hot end. I didn't buy the actual ones. I got the ones from China. They seem to be pretty decent actually for what they are. They're only about $12 a piece compared to the like $60 to $80 I've seen them go for. And I'm planning on having two on here. And the way that I have it mounted, I have it go to a thing, but I might possibly in the future make it so that I have a servo hooked up so that it'll switch between the two when it prints one and then prints the other one. Because you can actually add servos to the board that I plan on using. And that's also another very important thing that you want to have is determining what type of 3D board you want to have. The ones that I'm using is the Ramps 1.4. It's the board you can get really, really cheap on eBay. It's like $6-7 for the board. And then you plug that into an Arduino Mega, the 25, I think it's a 2560, something like that. And you plug that directly in, and that's what everything runs off of. And that's what I like to use, but you can pick whatever board that you want to get. They have more expensive boards that probably would be better that are about $30 on eBay. That has everything that you need built into them. But with the board, you have the Ramps board, then you have to get the controllers for the motors, the A0988, something like that. And you have to have one for each motor, and those plug right into the board. But you kind of want to make a list of everything that you want to get or need to get, and you can kind of develop that as you build the model. I really suggest building the model first fully in Blender or something, or whatever 3D model program you're using, just to get an idea of the dimensions and what you need and all the parts that you need, and build everything that you need, not just the basic designs. Build everything to make sure that you have all the parts that you would possibly need. I haven't built it yet, but I knew that I need them. The springs here, because I'm going to have the bed mounted on this rail here, the springs for tensioning and leveling. And this heated bed that I'm going to have, that's another thing that's kind of different that I'm going to be using. It's I'm going to drill holes spaced out pretty evenly on here. And I'm actually going to be using the print head here with a 6mm bolt going through it with 4 different heaters all heating up the heat bed. It might take a while to heat up, but once it does, it'll stay heated quite well because it's a lot of thermal mass that's here. It's I wish I knew the math to how to calculate that, but it's quite a lot. 6mm, it's about 11 pounds of aluminum. It's going to have to heat up. It'll probably take forever to heat up, but I'll find out later on. I might be able to do some other kind of heating as well, but I just have that as a basic plate for now. And I also designed gears for this extruder. This is the Cyborg extruder. I've had a lot of good luck with this one so far. It's on Thingiverse. I've actually uploaded my own version of this one. I'll put the link in the description for that one. And other things, that's the only model on here that's not my design, and I've modified it because I made it so that you could mount it like I have here with the bolts there, and I made it so it will grip the filament better when you try to feed it through. And other than that, everything else on here is is something of my design. And for the belts here, I was able to measure and accurately get the right type of belt that would fit exactly, but just in case, I actually made these spaced out just right here so you could actually move them. Like the whole thing's actually oval shaped, so you can move it just at about 2-3 millimeters either way, and so that the belt will be properly tensioned. And this is just basically going over my printer and what I plan on doing, but I'll go into more detail about every different part and kind of how I designed them. Like here, I think I have 8 total of the 12 millimeter 600 by 600 millimeter rods. Those came in at about $115. I'm not sure what the total is so far, but it's probably around $500 for everything I bought so far for the entire printer. But then again, this is going to be a massive printer, and so far all the tolerances have seemed to work well, and I just need to weld the frame together and get everything built and drill all the holes, and that'll be the other half of the video that, or the series that I plan on doing, is the actual build itself. I'm going to go over the design part by part on here and kind of show you what I do throughout this whole process, and then I'll actually build it at the same time, and I'll be posting both types of videos as well as the Blender tutorial videos. And that's pretty much all I wanted to show, is just kind of an introduction and an explanation of the printer that I plan on building. And if you have any questions, comments, feedback, let me know, and I'll get back to you as soon as I can. And other than that, if you like what I'm doing, go ahead and subscribe, and if you like it, give it a thumbs up. If not, give it a thumbs down. It's up to you. Anyway, thanks for watching.